Picture yourself typing parentheses, one character at a time, for 3 pairs, which finished strings are actually valid. Some of those arrangements are well formed, and some are not. A string breaks the moment it closes a bracket it never opened. Here are the 5, each one balanced, each one different. Well-formed means every close has an open before it. Never close what you haven't opened. The obvious build, 6 slots. Each slot is open or close. 2 choices 6 times. That's 64 strings. Generate every one, then keep only the valid ones. But look what you made. A string starting close is dead from the first character. For ento 8, that's over 65,000 strings, almost all trash. The waste is clear. You build a doomed string all the way to the end, then throw it away. Why finish a string that broke at character 1? Build one character at a time and never make an illegal choice. That's backtracking. Walk a maze, back up at every dead end. Track 2 numbers. Opens placed, closes placed. Add an open only while opens is less than name. Add a close only while closes is less than opens. You can't close more than you've opened. You might add a close whenever closes is less than n. That lets close open slip through. Tie the close to opens, not to m. When the string reaches length 2n, it's full and guaranteed valid. Save it. Start empty. Opens 0, closes 0. Only one legal move, add an open. Opens is 1. Still room, so go deeper. Another open, then a third. 3 opens placed. Opens maxed, can't open. Closes is less than opens, so close. Length hits 6. First string done. 3 opens, then 3 closes. Now back up to where 2 opens sat, and take the close branch instead. That fork grows the rest. Same rules, different choices, and every valid arrangement appears exactly once. Notice, you never built a broken string. Every path you entered could still become valid. The number of valid strings is the nth Catalan number, which grows about 4 to the n over root n. 5 strings at m equals 3, but 1430 n equals 8. Type it up. One result list, and a recursive helper that builds the string. Base case first. When the string is full length, it's valid, so store it and stop. The open branch. While opens is less than n, place an open and recurse. The close branch. Only when closes is less than opens, place a close and recurse. Kick it off from the empty string with both counters at 0, then hand back the result. That's the pattern. Prune at every step instead of cleaning up at the end. You'll reach for backtracking again.